Alright, so today we have a 2017 A1708 MacBook Pro that does not turn on. Now, this one's going to be a little bit tricky because this has been to another repair shop prior. Now, the other repair shop replaced the battery and said that the charge port was bad. Now, I don't think the charge port is going to be bad. I might be wrong. We won't know until we get into it. But what this does is on both USB-C ports, when we plug in the charger, we get absolutely nothing. There is nothing on our USB-C amp meter. There's nothing on both ports. This USB-C amp meter does work just fine. I can plug it into this laptop right over here. Actually, yeah, let's give this one a shot right here instead of reaching over for mine. And it does work, as you can see, and it does get to 20 volts, so it is not a USB-C amp meter problem. If you do encounter this, always double check that, because sometimes these things do go bad and you will get similar symptoms like this. Now, let's talk about charge ports on the A1708. The charge port is soldered onto the board. It is under the shield. It's kind of a pain to replace. But when do these typically go bad? Usually with liquid damage. There are some internal components in these. There's a little couple capacitors, I believe, under there that can short to ground and potentially cause this. But I don't really think that's what's going on here, because this is really, really pristine, and I typically see that when there's liquid damage. So what else can cause this? Usually an open or short circuit on PP-DCN G3 hot, which is our DC in power rail. That is the most common cause for this, is either an open circuit or a short circuit. Now, if I were to have both ports, both ports not working like this one is, that would probably raise my suspicion for a short circuit somewhere versus an open circuit. When we have CD3215 issues, oftentimes we'll have one port that has nothing, and that's usually an open circuit within the CD3215. But anyway, let's go ahead and get into this board and let's figure out what's wrong with it. As always, we're going to start with a visual inspection. So the other repair shop claimed this had bad USB-C port. Now, this port looks pretty good on all sides here. It doesn't look necessarily bad at all. So yeah, let's look at this other side. Usually when there's shorts, you'll see like a little crater right here, and I'm just not seeing it here. Again, that doesn't say there isn't, that's not saying there isn't a problem internally in the port, but I don't know. So our USB-C area looks fine. There's no notable corrosion there. These caps look a little bit funny. That's interesting. So I don't know what line these are on, but there is signs of heat there. That looks like heat. Those just don't look right to me. They kind of just, it's a red flag. So that's noted, but we're going to move on. So we're not going to look at like CPU areas. I'm going to look at charge circuit areas. Here's our ISL. Here's more caps on DCN. Those look okay. Carrying on right over here. CPU area, again, I don't really care. USB 3 mux looks fine. That's a common cause for problems too. So I think a very good starting point is just to check PP bus G3 hot, see if it's shorted to ground. Usually PP bus on this board, and it's shorted to ground, it'll be 20 volts and 0 amps, but I don't know. So in diode mode, we are going to check this and see if we have a short to ground. Again, I'd be really surprised if we found anything, but I just want to double check just to be thorough. I'm just waiting for my meter to turn on here. Alright, diode mode, we are reading 0.443, 444, 445, and climbing. So that is a normal resistance to ground on that, so I am not going to worry about that. So we know we don't have a short on PP bus G3 hot. The next thing I'm going to do, since we know we're not getting any voltage into DC in, I'm going to check our DC in rail. Now, if we look at our schematic here, I'm just going to pull it up right now. We can see there's something that's a little bit tricky here, and we're going to go over this. Okay, so here we have our schematic for our USB-C circuit here. We have our PP20V USB-C XA V-bus, voltage bus, whatever you want to call it. This is our input voltage for our charger, and this will be 5 volts or 20 volts depending on what the CD3215 requests. But the CD3215 is going to control this MOSFET up here, Q3200. Now, there is a MOSFET for each CD3215, and this MOSFET is going to let our charger voltage through to the system, and this is PP-DCN G3 hot. It's called something different right here, but it is PP-DCN G3 hot. So what we need to figure out is what is going on here, because something is not allowing voltage here. All right, this could be open, the circuit's not completed from a blown fuse or something, but a broken line, in the chip, maybe in the MOSFET, we don't know. It could be an open circuit, or it could be a short circuit. Something that is not allowing voltage through the circuit cannot be completed, and therefore we're not going to get any voltage on our ammeter or anything if the circuit cannot be completed, if it's open or short, just to reiterate. So let's say we check for a short to ground here and it's present, right? Okay, we know what our problem is. But let's say we also check on this side and it's also present. Well, where would the problem be? Well, we don't know, because our CD3215 is going to open this MOSFET only when it wants to. So if we have a short on both sides here, that tells us something went very wrong in this circuit, and now this MOSFET is essentially just a wire. Is the MOSFET short to ground? I don't know. Is our chip shorted to ground? We don't know. Something would be seriously up if that's the case. So I want to check for a short to ground on both sides of this MOSFET right here, so on our output side and our input side, to see what is going on. Let's go ahead and do that now. Alright, this is our PPDCN, our central PPDCN G3 hot power rail right here. You could always check on the board view if you're unsure, but this is what we're going to check. And we're going to check for a short to ground. So in diode mode, we're going to put our red lead on the positive side of this capacitor, basically anywhere that shows up green on our board view when we search PPDCN G3 hot, and the ground probe on ground. And actually we should do that the other way around since we're doing diode mode. Black probe on component and red probe on ground for an accurate reading, and we have 0.477, so we do not have a central short to ground. Now, if you remember, both of our PPDCN G3 MOSFETs controlled by our CD3215s feed into that central line. We could assume that no voltage is getting through, so that is a good thing, but something is still seriously wrong, and now we know that the issue is most likely going to be localized to somewhere right here. Now, the first thing I notice when I just glance at this, look at these solder joints. Now, solder joints should never be this color. This is what a solder joint looks like if it is... Basically, this is what it looks like if you solder without flux. Now, let's find a different MOSFET just to show you guys what a solder joint should look like, or similar component like this. Let's see. Which would be a good one for an example? All right, let's look at this BIOS right here. Alright, so maybe not the greatest example, but this one right here. Alright, so these are shiny and smooth. And they're shiny, silver, and smooth. Okay? That on this MOSFET right here, those are not shiny, silver, and smooth. Those are, one, kind of cracked. They're tan. They're very rough. That does not look good. What about our other one? So we have two here. Both are like that. Interesting. So what this tells me, look at this, it's really pronounced. What this tells me is that our MOSFETs got so hot that the solder actually melted on them. Now remember, a MOSFET is going to be like the thinnest wire, so it's going to get hot, but you know, if we have a short to ground, that MOSFET is going to get very, very hot, and it's going to be the thinnest wire, but that doesn't necessarily mean the MOSFET is the cause of the short. So I'm going to check voltage in our USB-C input voltage, and if we look here, it looks like someone might have already probed here. So again, it's been to another repair shop prior. I don't know, maybe it is shorted and they assumed it was the charge port. I don't know, but anyway, let's go ahead and check. Same thing. Red probe on ground and black probe on the component that we're using for diode mode. Apologize if I said it the opposite way around again. Earlier, I mean. And we have 0.0002 in diode mode. Alright, let's do both sides of the fuse. Same, but on this one, same, and same. Okay, so we have a definite short to ground. Now, why did this happen? Hard to say, but probably because the CD3215s failed in a way that caused these guys to fail. Now, it's quite unusual that it happened on both ports here. My guess is that a bad charger was used and it didn't work on one port, so it was plugged into the other one, which also killed it. So first things first, I'm just going to take off these MOSFETs, and I want to see which side the short is on this MOSFET. Because remember, this MOSFET is it's going to have two sides to it. I want to see what part of it is shorted to ground, because that is going to help me figure out where our actual issue is. So let's have a look. Now, I'm going to go to the board view just to demonstrate this. We're back here. Alright, so here's our MOSFET. We have this gate right here from our CD3215. We have our source voltage, and we have our output. We have just our two gates here. Now, something is wrong here. So which side? Is it on this side or this side? I don't know. If it's on this side, then we actually may have an issue with the charge port, or we might have a short here on one of these capacitors. I don't know. But anyway, that's what we're going to do on both of these, and we're going to figure out which side that MOSFET is shorted to ground on, and go from there. So let's go back here. I'm going to get my hot air on, and we are going to pull these off the board. Now, I have seen this before where they are so bad that they actually weld themselves to the board, so we're going to hope that's not going to be the case here. We're going to use plenty of heat. We're just going to heat until we know they're liquid. And actually, we're going to just slather this with flux. Just in case our CD3215s aren't bad, I don't want to cause any cold joints under them. So I'm just going to put a lot of flux down. We could always ultrasonic this after. Alright, this one was not welded. That is a good thing. Look at the bad condition of that right there. Look at that. That is pretty bad. There we go. Same thing. Luckily, it was not welded, so this is already a lot better than I've seen it in prior cases. Sometimes this is really bad. But anyway, let's go ahead and figure out what's what. So, back to our board view. The first thing I want to check is, we already kind of know this isn't shorted, so the only other option is either on our chip side or our 20 volts side, which that doesn't really make sense if it's shorted here. It just, because this MOSFET's really not going to get hot if we have a short before it. But anyway, carrying on, let's go ahead and see if our gates are shorted, so our 2 pins at the end, go from there. Or it's also possible that, let's see, no, maybe this is, yeah, it's got to be connected to ground in some way. Weird. Anyway, let's go ahead and check now. Alright, looks like it is going to be on our source side. Our output side is fine. Our gates are fine. Doesn't mean the chip isn't bad. The chip could have most definitely caused this already. It's quite unusual. Anyway, same thing here. Yep, okay. So let's go ahead and solder a little wire here, and we're going to have to thermal image this rather than just plucking these off. So I'm going to put this down to about 1 volt. We shouldn't need any more of this given the fact it is a pretty intensive short like that. Could use thermal imaging, or we could just do it with alcohol. Either way will show us where our problem is. If it's not apparent with alcohol, then I'll switch to thermal imaging. Big blob of solder so I can get my wire on there nice and secure. Let's get you in here. Good, nice, strong solder joint and ground. Pulling 2 amps at 1 volt. I'm going to up it a little bit just so it is extremely pronounced. Alright, 2.20 volts. I'm pulling over 4 amps. Let's get a really damp Q-tip and just feel around and see what gets hot. This may very well end up being an internal short in the charge port. I mean, that would be kind of surprising, and I would try and think of how that would happen, but it's possible. Anyway, let's go ahead and see. Charge port doesn't really get hot. A little bit right there. But it could just be because something on our board is getting very hot too. Okay. Diode. Look at that. There it is. Alright, and this diode here is going to be connected to, let's see. Interesting. So both diodes. So what about our other diode right here? Is our other diode the same? Looks like it's just this one. But that's quite odd that it's shorting both lines when this diode isn't even connected to both lines. That's odd. That's some trickery here. I don't know, but let's go ahead and take it off and replace it. Or at least take it off and see if our short is gone on both sides. Because remember, these are basically like two separate lines, but this was at least one thing. This diode does have a path to ground, and it's actually kind of bubbled up. Look at that. Yeah, that's definitely a problem. Now, this is actually a protection diode, so it did its job for a reason. It blew for a reason, which is really odd. So, let's go ahead and see if our short is gone now. It's quite odd a diode will fail like that, but it's possible. Alright, I have now 0.40 in diode mode, so that is our short. And I still have a short on the other side. Okay, interesting. Let's go ahead and inject voltage to the other side now. Guess it would make sense that diode wouldn't get hot on the other side because we weren't injecting voltage on that side. But that's really, really weird. It would blow concurrently like that, the same thing on both sides. I think this was power surge damaged. I think the charger was bad or something like that because this is very, very unusual. This is like surge or something. Let's see what this diode does on the schematic. So let's look this up on the schematic and see what it does, because to me this sounds like something, you know, this to me is like it's a Zener diode. That's what this does. I mean, it protects the circuit from surge, or TVS diode, I should say. I'm not a Zener. But anyway, right here, this is our main protection diode for the USB-C circuit. Our main TVS diode, which is it's going to blow if something like this happens, if there's a surge or something. Really, really common on spinning hard drives. The TVS diodes blow on them. So, very interesting. But my guess is either a bad charger was plugged in or the charger was connected during a thunderstorm, something among those lines. But definitely an odd fault. Alright, let's see. Connect our ground back. 5 amps. Same diode getting burning hot. Look at that. Very odd. The fact that it happened on both ports kind of tells me that most likely the device or charger that was plugged into this was plugged into both ports concurrently. Like it didn't work on one, so they plugged into the other one and the same thing happened, which is not a good thing to do, but it happens. That's off. Let's go ahead and prepare area for soldering. I want to wick all this nasty solder up. So I'm just going to add some lead free here, or leaded. I always get those mixed up when I'm talking. That's leaded solder. Let's wick this. Yeah, you can see it actually melted the copper pad a bit. Not totally uncommon, but I've seen it bad enough where it, like I said, it'll fuse, the MOSFET will fuse itself to the board, and that is terrible when that happens. So again, the MOSFETs were not the cause of the short, but they were the thinnest wire, so they did get very, very hot, and that ultimately led us to our diagnosis. Because we saw how hot that MOSFET got, given the fact that it was hot enough to melt its own solder. It'll flow into place nicely once we have more flux and put our component down. More flux right here. Like so. Let's grab a donor board. Alright, let's go for our diodes first. I'm going to go ahead and pull them off the donor board here. We want to be really careful when pulling these diodes. They're just silicon and it's very easy to chip and destroy them. So we want to be really, really gentle pulling them off. I'm gripping them very, very lightly as well. Okay, come on, go into place. There we go. And then for our other, same thing, we're going to be really gentle on it. And now for our MOSFETs. Definitely want more flux on that. Don't ever want my joints to look like that. That is perfect. Don't push these down either, just let surface tension do its trick. If for whatever reason surface tension doesn't do its trick, you either have too little or too much solder under it. You want just the right amount. I think I might have a little bridge here. Can't really tell. I don't think that's a bridge, but I don't like that bit of solder on this cap, so. There. Let it cool for a second. And just as an added precaution, let's check for a short to ground on both sides of the fuse here. Alright, so I do have a short there. Very interesting. I think it's because our board is still really, really hot. Let's let it cool down for a minute. Let's come right back because anytime you try and probe something when it's hot, silicon acts a little bit funny and it can mimic a short to ground. So let's come back when this is cool and let's just eliminate that variable. Alright, we let our board cool down. We're going to check again. Diode mode OL. Diode mode OL. Okay, now that's a good thing, and like I said, never measure on a board when it's hot when you want any kind of accurate reading, because sometimes you will get something that resembles a short, but it's not really a short, it's just the nature of silicon. And our resistance is well within the kilo ohms here, so we are good to go. I don't think we have anything to worry about here. And now what we can do is grab our amp meter and see if this turns on. So let's see. Moment of truth. I don't have high hopes. I think something else is going to be wrong in the USB-C circuit, like one of our CD3215s. But no, look at that. 20 volts and booting current on this board. That is amazing. That is an amazing fix. That is surprising, actually. So that is the rare case when a TVS diode on a board like this actually does its job, and this should be fixed. Let's plop it back in the enclosure, and let's see if this turns on and boots into an operating system. But it's usually in all the cases that I've seen, usually, this had to have been a massive voltage spike. I mean, for it to blow that diode, it had to have been massive. Usually, it gets by the TVS diode and ends up damaging our chip. That did not happen in this case. Our chips are most likely going to be fine. We're going to test USB data and stuff on them. But yeah, that is a very rare case when the TVS diode actually does its job. Our MOSFETs are probably fine, but do we really trust a piece of silicon that has been so hot with electricity flowing through it that it's hot enough to melt its own solder and melt the copper pad on the board? Probably not, so we obviously replace those for good measure. But anyway, let's put this back in the enclosure and let's see if this boots properly into an operating system. If so, it's going to go to ultrasonic cleaning, and this is a done deal. So let's go ahead and do that now. Alright, we have our critical devices connected, our trackpad, keyboard, whatever, just not our battery. Let's go ahead and see what we get. So I do have trackpad click indicating the board is basically alive. With any luck, I should get an Apple logo here very shortly. Make sure double check our screen is connected. Yep. Steinsies take a minute to post. We're just going to give it time. There we go. That is backlight. And come on, give me an Apple logo. Look at that, it booted right up into the OS. So there we go, this is fixed, and this was a pretty interesting case. This was actually a pretty fun one, to be honest. And that's it for today. Hope this video helps you in some way. If you come across a similar problem, if you have a laptop like this that you need fixed, visit our website at www.tcircircuit.repair, and we'd be happy to help you. Thank you very much, and have a nice day.